All right, so now that you have a basic understanding of how neural networks work and what their general structure looks like, we're going to go ahead and implement our own neural network, an image classifier for the FashionMNIST dataset. And the dataset we're working with, it's called FashionMNIST, and basically just consists of these black and white pictures, 28 by 28 pixels, so not the greatest quality, but simple enough for us to use in our model. So we have this 28 by 28 image, and each one of these maps to a label. So this first one maps, to shoe. This next one maps to shirt. This one dress, etc. So our goal here is first, let's just download this data set. So I'm going to go ahead. So I have Visual Studio Code open, but let me also open my terminal. And this is actually a good example also of how you just get started every time you want to work on your project. So let me open up my terminal here. So again, before I start working, the first thing I need to do is move into whatever directory my project repository is. And again, I'm using the workshops repository, but you would be moving into wherever you cloned your project repository on your computer. And again, I don't have a project repository, so I'm just using the workshops one. But I'll go ahead and do that. So in my computer, I made this folder called YML. So I'll cd into YML. And then if I do ls, I see, okay, there's my workshops repository, so I'll cd into there as well. And then after this, we have to remember that before we start trying to, run code or write code, we're in our base environment. So we want to be working in our virtual environment at all times, because that's where we installed PyTorch. That's where we install all the things that we need for our project. So I'll do conda environment list. And this will print out, okay, here's all of the virtual environments on my computer. And okay, I remember that this one was called workshops for my workshops repo. So I'll do conda activate workshops. And now you can see, okay, we went from base to workshops. So now we're in our workshops virtual environment, working in the workshops project repo. So you'd want to do the same. You want to activate your project virtual environment, and then also make sure you're in your project repo. And then here, what we can do now is, let's go ahead and make a new file. So I'm gonna do split view so it's easier to see. Let me call this, get rid of this guy. Okay, so let me call this, and I'm gonna do this in my terminal, but it'll also happen in VS Code. So we'll do touch, and let's call this tutorial.py. And now you can see, okay, it just made this file tutorial.py. So let me go ahead and open that up and double tap that so it stays open. And now what we're gonna do is let's just maybe install our, or set up our data set. So I'm gonna import, let's just import PyTorch, import Torch first. And then the data set itself is from the Torch Vision, import datasets. Torch Vision, again, when you set up PyTorch, you ran your command, Torch and Torch Vision and Torch Audio, they're all in there, so you'll already have this installed. And if you don't, you can rerun your PyTorch install command and it'll install that. So the first thing we'll do, so actually let me set this up in our main. So if name, these are double underscores, so if name equals double underscore main. So this is just Python syntax, main function here. So what we'll do is first we can download the training data, and we'll do training data equals. So from this data sets that we imported from Torch Vision datasets, we're going to use the one called FashionMNIST. And because we're downloading it, it takes a couple of parameters. So the first one it takes is the root directory to look at, and this is just going to be the data. Are we using our training data? Yes, for this case, we want our training data, so we'll do train equals true. Download equals true means that, okay, we're assuming we don't have this downloaded already, which we don't. So we'll set download equals to true, and then we'll also do a transform to tensor. And again, a tensor is just a kind of like a multi-dimensional array. You can think of it as it's able to store any kind of array or matrix, so we'll just turn it into a tensor. And you can see that, okay, well, Pylance is actually flagging we don't have toTensor because I forgot to import it. So let's import that. So let's do from Torch Vision dot transforms import to tensor. And this will basically just take the raw data from FashionMNIST and just turn it into a tensor so that way we can use it in our PyTorch code. And let me do this for both training data and the test data, just so we can have that here as well. So test data equals datasets.fashionMNIST. Pretty much the same thing. Actually, let me just copy this because it is the exact same. The only difference now is that we're using our test data. So we'll say train is false. We want our test data now. Cool, but now we've downloaded our data, and let's actually just run this, and maybe let's print out like training data 0 just to see what it looks like. So this is the first element in our training data. And let's just run this and see if it works. So we'll do Python 3 tutorial.py. Let's run this. Sometimes this can like give some errors. Okay, looks like for this time it was fine, but sometimes this gives an error like, oh, HTTPS request failed, or something like that. If it's because it's really just trying to fetch the data from this link here, and if it fails, it'll kind of give a message. But don't worry, just run it again and see if it works. And if it doesn't work a couple times, then message me on Slack and we can try to sort that out. But cool. Okay, it looks like it printed out our first training example. And actually, this is a good time to think about, like, what does this actually mean? So let me go back to our picture here. So we said that our input was this 28 by 28 image. And if we were to go back and let's just look at this first row here, this is, if you counted it, it's 1, 2, 3, 4, 5, 6, 7, 8, you know, it's 8 to 27. 28, so it's 28 pixels here, and this corresponds to the top row. And if you kept counting, I'm not going to count it, but you can trust me that there is 28 more of these guys, and each one of these corresponds to a row in your image. So what you basically have here is this 2D array, this 2D matrix. That's exactly what your image looks like. And I think if I expand, okay, yeah, so it doesn't actually fill up the entire terminal, but you can imagine that this entire thing is just this top row, etc. And then that's great. So we have our data downloaded and we're able to print it out. But one thing to notice is that we have this kind of 9 just by itself. So this is outside of the array, really the tensor that was storing our image. This 9 here represents the label of what image we have. So actually, if you're curious, you can Google FashionMNIST. And you can see that the labels are right here. So it looks like the first image in our training data that we had was a ankle boot or like a shoe. So that's what we had there. And if you had more stuff you were curious about, you can kind of read about the FashionMNIST dataset in more detail here. But that's the idea, that we have our very first training example is one of these images as a tensor, or really like a 2D grid of 28 by 28 numbers, where 0 represents black. So this entire first row is all zeros, probably because the entire top of it is just black and the shoe's kind of down here. And then in the middle, you kind of see some more higher numbers, which represent pixels that are like, have a lighter color representing one of the articles of clothing. But cool, okay, so that is how you can make sure, okay, we have our data downloaded, so we're good to go. What we'll do next is let's go ahead and just set up our main neural network architecture. Let me actually first move to my iPad and let me kind of just walk through what exactly we're going to be setting up architecture-wise. So we have our data set again that was 28 by 28 images that we're mapping to a label, and 0 represent a t-shirt all the way to, I think 1 was like dress or something, all the way to 9, which was ankle boot, or like, I guess like a boot. But that's the input-output kind of mapping we have. So for designing our neural network around this, we need to consider, okay, what does our input layer, what does it look like? How many neurons do we actually need? Well, the images that we have are 28 by 28 pixels, And we know that each pixel is just a number from 0 to 1. It's 0.0 if it's a black pixel, and it's 1.0 if it's a white pixel, and if it's anything in between, it's whatever shade of gray that is. So if we have our input that's 28 by 28, we really have 784 like numbers that we're representing, or that are being used to represent each image. So in our input layer, we can have 784 neurons. So that way, you just take your image. It's a 2D grid at first, but we can like flatten it to just make a single 1D array of 784 values. So we can have our input layer 784 neurons, and then the hidden layers are really, again, a design decision. You can decide how many hidden layers you want. You can decide how many neurons are in each one. So you're designing the depth both of each layer and the overall depth of the network. We'll keep it simple. We'll just do 2 hidden layers. So we'll have hidden layer 1 and hidden layer 2. And for our purposes, we'll just go ahead and have 512 neurons in both of these layers. So we'll have 512, let me actually write it in the bottom. We'll have 512 neurons here, 512 neurons here, but they don't need to be the same. You can decide whatever number you want for your hidden layer. So again, for each node in the layer, it's connected to every single node in the previous layer. That was not a good line. So it's connected like this to every single node in the previous layer. And it's like that for every single node here. And you can imagine, I think I missed one. Okay, there we go. So that is connecting our input layer to our hidden layer, and then again, our hidden layer is also connected to the next hidden layer, same exact way. And the most important thing to think about is, what does our output layer, what is that supposed to look like? Well, we know that we have 10 classes of images, right? We have images that could be a t-shirt, it could be a dress, shoe. So we have 10 possible labels. So we need 10 neurons to represent that output. And again, if this one lights up, we know that it's going to be a t-shirt. If this one lights up, we know it's going to be a ankle boot or shoe, etc. So we have our 10 output neurons. So this is the architecture that we're going to be implementing. We're going to have these 4 layers. We're going to have our input layer, mapping to our hidden layer, mapping to our next hidden layer, mapping to the output. So let's go ahead and jump back into PyTorch and code this up.